Okay, before the break, we were talking a little bit more about normalization, in particular because normalization is very confusing. And typing SQL code is not very confusing. So I wanted to spend a little bit more, as much time as we can on the confusing part to try to clear that up. But we got our example from Monday, which was intentionally left in denormalized form or unnormalized form in a particular manner that software developers are going to encounter a lot to see how that fixes, because that particular manner also blocks some of the functionality that we depend on relational databases having. So we went around to normalize that, and when we went to upload it and create the database from the schema, I realized I kept forgetting to use that word the other day. Let me open it. So when we put all of the SQL code here, we took our design and turned that into a file of SQL code. That's known as a schema. So for your final project, that's what you're going to submit. On the first deliverable, which is the last thing that I'm behind on grading, so I will get those graded very soon. The ones that the group turned in, you draw the picture, draw the diagrams, and I think I mentioned it the other day. You didn't realize that the person that draws the diagrams usually gets paid more than the person that writes the code. They would have a title usually along the lines of architect or engineer, something like that. And the coder makes a little bit less, but it's still a really good paying job to write the SQL code. But once we take that diagram and put it into a file of SQL code that's ready to be uploaded to create the database, and oftentimes insert the database as well. Maybe not. Insert is relative to that. So with all of our insert queries commented out, this is definitely a schema, because insert is getting into actions that we take on the database. So this is what you'll submit for the final project, which your group's going to do next Thursday. Which, as that installer was running, because I just deleted the virtual machine and reinstalled it, it turned out what the problem is under a recent update, which actually ran last night before I went down to the concert on the waterfront. I saw there was an update, so I went ahead and hit it without checking what the update was. And it apparently put out OneDrive back into my registry. But since that virtual machine was installed when OneDrive was not in the registry, it messed some things up. So after class today, I will go take OneDrive back out of the registry and reinstall Jamf again for a second time today. But that's a side point. It's reinstalled, it's working, and when I was reinstalling it, I was thinking about some stuff, and we'll probably continue the sequel into next Tuesday, which will push everything back by a few minutes. So next Thursday, when we have our next on-campus required day, the other day for your group work, where you will take those ERDs you drew last week and create a schema from them. Right, that's going to be a pretty quick day, right? There'll probably be about 20 to 30 minutes of lecture about JSON and XML before we split up into groups and do that stuff. I have some things to say about that I will put in an announcement. So please don't jump the gun and write the SQL code for your group ahead of time. There's reasons why I want you all in the same place writing the SQL code, even though one person could write that and submit it for the group. Please don't do that yet. There's some other things I'm going to, some other fine touches I'm going to throw in there that day, so that we are all working on that. But that's for the future. I guess the main point for now is don't jump the gun, even though you have the design. Don't type the SQL code yet. I'm going to make some adjustments when we're all in the classroom together. So upload this. Oh, I probably should have renamed that as SQL Day 2, but I'll do that before I share that file with you all. Import that and see if we got any typos, because I was talking the whole time I was typing. And there's probably a typo because it took a long time. It's really, really quick if there's not an error. You have an error in your SQL syntax, check the correspondence to Maria server. Can't see the line number. Line 10, we looked at this the other day in an error message, right? MySQL does not count line numbers the same way we are. So there's nothing near that here. Oh, here's the problem. I got an extra comma. This is all one line. It's only split up in order to for readability. And actually this, I shouldn't say line. As far as MySQL counted it when it told us line 10, this is not even a line. This is one item on that line. But there's an extra comma. Line 22 in my file. So in the skill set where we did the first constraint and then foreign key, I accidentally put a comma at the end of there, and then that was copied and pasted. So that error is going to show up a couple more times. So save that and give that another try. And since we did not put if not exist everywhere, you want to make sure and drop the database because we can't create things that already exist. So I'm just going to delete it every time. And when the box goes away, I'll click the button. Import. And you all know this process, right? Over half the class is software developers, and the others nodded their head yes when I asked about it. So y'all have seen a little bit of writing code, fix the type, run it, see what went wrong, fix the typos. Okay, this one's a little bit harder to narrow down. The right syntax to use near this. I bet I know what it is. Mostly just because of this. So once again, we can't really identify what line 17 is because MySQL does not count these lines the same as we do. Semicolons would be the best version of a line, but it still gets a little bit off. And we added a whole bunch of white space in here to make it nice and readable because it's really, really hard to work if we don't have the white space. Line 17 is probably down here somewhere. Oh. This right here, we don't need that last comma. I think that was running from the, oh, probably is there. So I'm gonna take out that comma. Are there others of those? Yes. And that comma. And that comma. And I just know it's an extra comma because of doing this a few times. Team, oh, this one. Okay, no extra comma on that one. Let's see if that fixes the typos. I usually expect a lot more typos to happen in class examples than what I see because typos happen when we're just typing. And I'm standing up here typing and talking at the same time. Oh. Foreign key constraint is incorrectly formed. Oh. I apparently missed that change somewhere. Grab this and just search for it everywhere in the document. Oh, well, there's the problem. There should be something called skill set that comes into the other table. In there? Oh. Because of that. Skill set. One key is employee ID, which is an integer. Let me see if that fixed the problem before I describe what I did there. So this is what we were seeing the other day. You remember searching for that? Most of what we would see would say that point us towards type data, could be a typo. I don't know which one's incorrectly formed. But if I highlight employee ID, it doesn't highlight elsewhere. Employee ID. Employee ID as an integer, or equipment ID. Integer. Uh-oh. So notice it gave us the SQL code we needed. Okay, foreign key employee, employee ID, versus employee ID. Oh, this is stuff we haven't talked about while I'm looking at errors. Sorry, this was not a planned error, so I actually have to track it down here. Where did it crash at? Do I need to retype something? Does anybody see a typo in there? I'm just gonna do this. How far did this go? Um, Remember employee table. So after employee, skill set. So it crashed on the very second thing. Okay, so, a little inconvenient. I'm gonna do this. I'm gonna take all those foreign key constraints and pull those out of there so that I don't have to waste last time looking for the error. Because I already wasted a bunch of class time looking for that error and I just don't see it. All right, now I'll try that. Because for the rest of what we're going to talk about today, we won't need those. The symbol was expected near, let's see. This stuff? Sorry, I have no idea where that is happening at. Okay, the comment's not commenting. I'll do it this way. So in most text editors, you just hit Control/, it'll comment things out. So I will comment those out that way. And we talked about the purpose of it. So other than that, it's not going to apply to what we're doing the rest of the day. We need to get up to the insert and the select queries pretty quick here. Oh. I'll do this. I just made a really silly mistake, but I should point out to you all what the mistake was. I put a bunch of single line comments in there, thinking I could comment that out. But the white space is just there for readability. So those aren't actually commenting anything out. I'm going to put them back in later, so I'll keep that one around and just go with number 2 here. And get rid of those because I don't see the typo and they're causing problems that won't really matter for the rest of the day. All right, quick scrolling. Got all of them. Okay. Hopefully that fixed it. And forgot to take the comma out as well. And we've already seen that today. If we put a comma after the last item, it will throw an error message. Sorry, that wasted a bunch of time and I have no idea where that typo was at. what's there a typo here? Create table usage. I'll retype this one. Apparently I made a lot of typos there. That's already been over 10 minutes now. Sorry about that. So we can. Create table usage. Okay, it was trying to make that it was trying to use the SQL keyword usage, not the name usage. I guess I also could have fixed that by putting the quotes on there. Okay, sorry, that, I did not intend for that to waste nearly so much time looking for typos. But we got all our tables. Oops, my triggers. Notice it recognized a couple of the connections, but not all of them. I will fix that. Oh, I will track down the typo for the foreign keys after class because they don't really relate to what we're doing here. Notice customer ID and team ID were named the same, had the same data type, so it was able to recognize those. There should be at least one other. Oh, no, that's the one that would, never mind. That wasn't recognized. That was the one that was in there. Let's see. Should take us about 20 minutes to do the other stuff. I wonder if I can get this in here. I would like to finish it, but let's go to inserting data. So I'm going to go over here and copy one of those lines, the one that was just a single line. And for some reason, it's not recognizing the multi-line quote or multi-line comments. And that's an awful lot of lines to comment out individually. And they're not separate lines. With our text file, we can't put the comment symbol on every line in the text file. So if you had those from copying the other day, you might want to move them over to a new file. And I'm going to copy the single line one, because then we can paste that in here and just get a bunch of adjustments. So what do we need to insert? We need some employees. Employee number 1, named Sally. I guess this is the only picture of it I have left. And our employee table needs the ID, the name, and the salary. In that order. If we don't put it in order, we have to say explicitly what fields we're going to. Salary, name, ID, name, salary is 123.45. So I'm just going to copy that and paste it in a few times. That's why I did it as one line, so that we have a few employees. 2, 3, 4, Bob and Becky and David, just make up some names, but that's probably good for that. Then we have the team. So we have team 1, and our team needed the ID and the date. So team 1 was on now. I'll do that in all capital word. Yeah, that worked. 2 teams. Now that we have employees and teams, sorry, is everybody back to paying attention after that time waste looking for an error that I never did find? So when you submit the schema, you will also submit a bunch of insert queries, probably in a separate file. Actually, I'm going to do that. I'm going to go over here, create a new file, and put these in here. And this is data.sql. So it's 2 files that we need to upload now, but they're separated. So a problem in insert queries won't mess up creating the database. And just a little bit of organization. And then we'll have 2 2-person teams. Get back to that picture I want to point out anyway. And then those teams and the employees get put in the assignments. So, once again, I'll copy one of these insert queries, which I'm starting to move fast because I'm worried about all the time wasted looking for that typo that I never did find. Really, we probably should have ran one insert query before copying and pasting and editing it. So this needs to go, we'll insert into assignments or assignment table and an ID, the team they're on, and then the employee that it is. So assignment 1 will say on team 1, we assign employee 1. Copy that, paste that, and our second assignment is team 1 also gets employee number 3. And our third assignment, team 2 will get employee 2. And then for our fourth assignment, we'll say team 2 also gets employee number 4. Hopefully that makes sense. And we always want to make sure we have at least enough data to do a thorough minimum test. We should be assigning to multiple teams, so we need at least 2 teams. And then we'll need at least 2 jobs afterwards. So we'll probably need 2 customers when we get down there. Employees, assignments, teams. We'll do jobs last, but we need to insert some stuff into equipment. What equipment do those teams work with? And we need an ID, a serial number, and the type of equipment it is. So ID one, let's say serial number 12345 is a mower. Oh, another one I meant to copy. Copy that one. And 987 is a weed eater. Paste it, serial number 4444, be a chainsaw. Um, 91, some serial number that would have come from the manufacturer on the equipment, because we always need to keep track of that. Which, if we need to go to the higher normal forms, that serial number makes a much better unique identifier than the integer we made up just for this. What else would there be? Mower, weed eater, chainsaw, wheelbarrow. Since we're Americans, we say it this way. I'm gonna write wheelbarrow. I know that's wrong, but we're Americans, that's how we say it, and those words make sense. We put wheels on a barrel. Um, we need to tie those together with skill sets. So we'll insert into the skill set table. The first value needs to be, actually, it needs to match the way we created it. So our first value on skill set was up here, I think. The ID, then employee, then equipment. So employee number one knows how to use a mower. Copy that. And employee number one also knows how to use a chainsaw. And this is what we have to do with our arrays. Notice that, I guess it fits with the text file too. Here with assignments, we're duplicating things vertically, not horizontally. Actually, that fits in the text file just as nice as it does on the table picture. So in the text file, when we write our SQL code, it's okay to do for duplicates vertical. And that's what you need with the normalization thing. Employee number one maybe also uses the wheelbarrow. And I'm writing wheelbarrow, not wheelbarrow, because we're Americans. And what the thing is, it makes much more sense to put think of wheels on a barrel than think of wheel and a barrow, which is something very, very different than a barrel. Because we need a couple more of those. So employee two, employee three, and employee four at least need one skill. 4, 5, 6 unique identifiers for each one. Weed eater, and what else was there? Yeah, that's probably good. Enough for a test case. So we have enough of a test case that we can duplicate what was a JSON array earlier. What do we have? 2 more tables. Thanks. Oh. Copy that. Paste that in. So usage, when we use the equipment, and we need to refer to a team as far as who used it. A particular piece of equipment was used by a team member or on a particular team. So we have two teams. Team two, maybe team two used the mower. And, oh, that name changed, didn't it? Used on. Usage is a keyword in SQL. It tells us to do stuff, but usually we can manipulate that. It's like using the word name as a variable. Yeah, it's probably built into most programming languages, but we can still get away with using it as a variable. But for some reason, usage was not working. Two, maybe team two also used a wheelbarrow. And team one, oh, whoops, 3, 4, and maybe team one, I'm keeping on two. Team two also needed a chainsaw. And team one only needed a mower. So you see, this one takes a little while as well. But at least for your test cases, think through a situation where, try to think through a real situation and what would be happening on there. Now we need some customers. And I think we need at least two customers. So customer number one, person at person.com. And we need a name and an address. Somebody, somewhere. Good enough for test data, right? And we'll also have a human person.com. Nobody who lives somewhere else. It sounds like a good address. And finally, we can assign our teams to do jobs for these customers. And jobs need an integer for the ID, what teams involved, what customers involved, and how much money are we making from the job. So I'm going to leave that. I'll need that ID in a moment. So I'm going to job one with team one, the customer, and then the price at the end. There's the customer, so we just need the price here. 345, 45, 34. Job two and job three, both of those were carried out by team two. Only one of them for the second person, and then some different number. Okay, a whole bunch of insert queries. That is a very, very repetitive part. And there is not a way to abbreviate that. So also for software developers, that is something that data analytics people are going to ask you to make, is a GUI that automatically writes the insert queries so that they can just use a nice little box. And guarantee you people want that from every software developer. You'll be asked to make a nice little GUI to create these insert queries for them, because there's not a way to shortcut it. And we just wrote the bare minimum test data for our small classroom example database. In the real world, there's a lot of data that needs entered. So that's a whole lot of typing insert into employees. And normally we would have some field names here field names, the values, and then all the stuff we want to put in there. We can omit that as long as we're putting data into every field in the order we created it. My SQL does know which order we created those in. So if we use all of them, it will just throw them right in order. Now we can just go bring this query in. So make sure the breadcrumbs say you're using the correct database. That's fine. I deleted this. And bring in that. Oh. Was that the very first line? And the insert query, it won't hurt to insert extra data. So I'm not even going to go check to see if some inserted. Line 1 crashed because I put employees instead of employee. The normal typos, I think everybody in here is already familiar with those parts, right? I'm just going to go try to run that again. Unlike the create queries, it won't block us if we do that. Oh, same thing with customers. And job. I followed the standard convention of doing it that way. Now, since I know it made it down this far, I'm just going to copy those and run them here locally. So put them in here, and then there's a button that says go, or you can usually hit Control Enter. What? Incorrect integer value. Let's go look at the table. So for job, the structure is int. So job, ID, team, then the out. Customer first. And when it fails, it did not run that. So that was on team 1. Then the rest of these were on team 2. And I will just copy and paste this. But unlike the create queries, it wouldn't give us an error if we just ran that again. There we go. And notice the time. Because now that we have some data in here, now we're ready to look at select queries. That's the thing we're going to do the most often when using it. There's a big deal about talking about it, which is joins, and that's what I think that's going to get pushed back to next week. So that we're not here to 3:50 today. There's going to be quite a bit to talk about. But when we get to select queries, take note of how long it takes. And we're on little bitty sample sizes, right? So if it takes that long, to insert one row, well, really, when we get to select queries, if it takes a certain amount of time to select one row, and we have 1 million rows we need, how quickly does the time add up? That'll be a big issue. So now we should have a bunch of data in here. You can come over here and see it. Assignments, it's kind of hard to make sense of what's going on there, right? But that's not a human table, that's a bridge table. There's not even any data in there. There's just pointers to other tables where we're actually storing that data. But it's an important thing as far as getting that together. Like that's pointing over at the employee table where we see the data we actually want. And to show it, the reason that was in the SQL tab already isn't the prediction thing. We just looked at the table, and in order to show that table, it had to run the select query. So the asterisk here That's the wildcard selector. The asterisk can take the place of any character. So that's saying select, fill in the blank from this table where one, and in this case, that's one is in true as far as one is true and zero is false. So every condition is met. That's our general structure that we want to do. We can do a little bit better. We can narrow it down. We're trying to do this a little bit different. So maybe we just want to select name from employee where name like S asterisk. So we can also use the asterisk over there. So S and then any other letters we can fill in afterwards. Question mark fills in one character. So like if we just can't remember how to spell something, we know it's close. We can put a question mark and that will fill in one character. If we put an asterisk, that'll fill in every combination of things. So we obviously can't do equality if we only know the first letter. Okay. We met the lady once. Remember, her name starts with an S, but we're not sure. Can't really remember exactly what it is. So we can just check and see what things are. Where do we have names that are like S something? Oh, it didn't return any rows. Didn't we put one in? We've got a Sally there. We're going to put equals. Some databases will let us do an equal there in place of like. Nope, I can't find anything that's like S and then some other letters. It's really small on the screen. I don't have a good zoom on this one. But do y'all see what I changed there? The wildcard selector was inside of the quote marks. So inside of the quote marks, we're explicitly telling the computer explicitly look for an asterisk. Now we're back to the intended errors to put in there. Uh-oh. We get something like this. The error came from something that we didn't even type in there. Notice that it rewrote our query when we ran it through. Like name from all this where S is where it's like S, then some other stuff. Limit is how far do we look into it. So somewhere between 0 and 25 characters. But that gave us a problem. Equals. Again, equal. We can't be equal to a fill in the blank. I wanted to point that out. I will leave that to you all to go check how we do similar things. Wait. Employee where name is like S. Yes. I'm gonna leave that to you all to fill in the rest, but in general, we'll be doing, we'll start with simple select query. Select name from employee where employee ID is equal to 3. This is what we're going to do the most often. This is the starting point. I closed that Excel thing earlier tonight. Yeah. We can jump right to the employee ID column over on the hard drive, and just check those one at a time until we find the one that's equal to 3. Then we grab that whole row, grab our one, and find the name column from that row, and then that's all that gets sent back. So we do, and then that name column, just that one thing gets sent back. Or employee ID equals 2. So what's employee number 3 and number 2? What are their names? Kind of asking questions like that. We have 2 rows, 2.000. Is that 4 zeros? Yeah. Yeah. In our test case, we could have looked, but in particular, 0.0003 seconds to get those 4 rows, or those 2 names from the hard drive into RAM, and so that we could show them on the screen. Time adds up quickly. That is really, really slow because I'm on a Zoom call and using MariaDB and Google Chrome. And between Zoom and Google Chrome, they're probably not letting the database have hardly any RAM at all. Google Chrome and Zoom are both probably telling RAM that they need or both telling the CPU they need the RAM that the CPU wants to give to the database. Like, no, we can't share that. We need the RAM to show web pages. Google Chrome. Both of those use a lot of RAM, so that's kind of slow. But what would it be if we needed 1,000, or if we needed 2,000 names, not 2 names? If we could multiply that number by 1,000, and then we're approaching a time scale that humans would notice the delay. And 1,000 is still an incredibly small data set for the modern world. So that's why we're looking at this stuff, because we need to optimize that. Let me go someplace where I can zoom in here. I'm going to go here so that we can come back over here and maybe look at this stuff if we need to. I have MySQL installed here. No. There it is. Okay, I'm going to go over to the terminal and do it because I can zoom in here. For running select things, you probably need to be able to see that. The only zoom I have on PHP My Admin is to zoom in on the page, and if I do that, it's going to make that area smaller, and it's still going to show the little bitty text inside of it in a smaller area so that it can show more of the page. So really what we're doing is passing the commands from here. So we show database, show all the databases we have. So there's one we want. And notice that MySQL Tota's lawn care is written in all lowercase letters, but we created that, so we know that's not actually the case. It was written with a capital L. So we want to use lawn care. And notice our prompt now shows us which database we're using. And there is not a clear in MySQL. So what I usually do if I'm over in the terminal is I will exit MySQL and go back to the regular terminal where there's a clear function, clear the screen, and then come back in over and over again. And just run those 2 lines. But really, we don't need the first line because we need the second line to say which database to use. But now that we're using it, we can show the tables we have. So we have that reference somewhere. And if there hadn't been a typo in those foreign keys, we could show a lot more things. We could show the constraints, and then we get the names of every relationship we have so that we can use those and filter through things. So a preview of what we're going to do. So select employee.name and team what was our date called? That was one we didn't touch today. Team date. Team date from the employee table, but, well, you'll notice from the dot, you can probably infer pretty quickly from the dots there, the team date is not on our employee table. So what we have to do is join that to another one. And I'm going to put in the word join, which by default is going to give us a cross join. We're going to talk about joins before long. We'll talk about what a cross join is. That's the reason that we took a moment to talk about what a Cartesian product was. But it's going to give us a cross join, which is really every possible combination of employee names and team dates, whether they line up or not, which isn't really what we want. We need a better way. Join with the team table, where employee name equals salary. So we're going to check multiple tables here and look for dates where Sally was on the team, which I'm gonna run that. So we got 2 dates, but Sally was only on one team. So that's the cross join. It pulled every combination. It did the Cartesian product. Let me remind you what a Cartesian product is. And this will work to start practicing, but it might the next thing, which we'll talk about Tuesday, is improving joins. So remember, if we have a couple sets, A maybe is the numbers 1 and 2, and B is 1, 3, and 5. Then our Cartesian product of A cross B is every combination we have of those, where the first element comes from A and the second element comes from B. So we could have a 1 with a 1, or we could have a 1 with a 2, or we could have a 1 with a 3. Or we could have a 2 from the first set and a 1 from the second set. Or a 2 from the first set, a 2 from the second set, 2 from the first set, a 3 from the second set. So it gives us every possible combination. We have to check if we just throw out the word join, which we really shouldn't do because it defaults to cross join. There is a purpose for cross join. We'll talk about when we want to use that. It defaults to every possible combination of them because Sally is only on one team. So if we look at the assignments, select everything from assignment into instruction. Sally had ID 1, but I guess Sally is on 2 teams. So that worked out. Yeah, that worked out, but not for their the long explanation. It was a bad example. The long explanation I gave. We got 2 dates because there are 2 team dates, not because Sally's on 2 teams. In this case, so maybe not the best example, but that particular thing. So we're going to select this, but we're going to join the teams. It's kind of like another keyword. And I'll kind of wrap up here. We'll improve this one more topic. We might as well have done this. Select name from employee, where name equals Sally. Union with, so if you remember from math class, union is the big cup symbol and it corresponds to the word or, but or means something different. Or is used in a condition, so it would be ambiguous to use or for the entire query if we have a bunch of ors in each one. So we need the other word for or. So union with select team date from team. Yeah, I'll just do it there. So that's an equivalent. That's equivalent to what we just did when we ran that. When we just used the word. When we just used that one word to join those tables together. We didn't do anything explicitly about joining them together. So we might as well have ran this entire query or this entire query. And it's an or situation, so we get the results from both queries. Slightly different order than we saw them the first time. But notice how it gave it to us too. We'll talk about what the format, where we would want to use or, where we would want to use different joins. We will start combining them. Well, I'll do it on the board with a marker for a quick picture. Everybody's seen Venn diagrams before, right? So with this, we have our 2 sets and we color in some of each one. I'm going to grab a couple different markers, different colors, because if we just use join, then that gives us every combination. So our Venn diagram from joining them that way would give us all of the first set and all of the second set, and then do it again. We're looking at our entire data collection twice. Not the best way to look at our data set, right? Okay, if I erase some of this. The reason we're doing this and this is what we're gonna talk about on Tuesday, is it'd be nice to cut those down. The thing we want, main functionality we want from our relational database is that we don't need our entire data set. We only need part of it. So like on the Venn diagram, it would be a lot nicer if we only looked at that part. Because obviously that's going to take a lot more time. It takes a lot more time to look at the entire data set twice than it does to only look at what they have in common. Or the opposite of that, to only look at what they have different. Once, not twice. Or that one's small. Maybe we just want to look at this part over here. So the next thing is talking about joins and unions so that we can get away from that looking at our entire data set, possibly 2 times, and filter down so that we don't waste time looking at things we don't need. We know the part we care about is in the intersection, and that only applies to our conditions. So the where something is greater than something, or that's the only part we care about. So it'd be nice if we could filter it down and only look at the spot where that's going to show up. So that's the one we really want to use, but sometimes we might have to look elsewhere. The only thing we know for certain is it is definitely not in the stuff they have in common. So only look at the parts that are different, or only look at one table where it's different. So that's the next thing we're going to look at with queries. That's joins. So that'll be Tuesday. But select queries are in general fairly straightforward. We follow that basic syntax of select something. This is going to cause a typo, so be careful copying this exactly. And sorry, I got to move this because Zoom thumbnails are in the way. Select something from a table where we have some condition. We want to choose something. We want to filter down our data. We don't want the whole data set. Where do we look at it? And what is our condition for filtering it? So we have the tables up here. So maybe we want to choose customer.name from our customer table. Where let me do another. Yeah, I'll just do where customer ID is greater than 1. End of instruction. Oh. Did I spell it wrong? Oh, wait, because that's not an integer. Sorry, I'm going to switch that to employees. Let's look at employee name from the employee table where employee ID is greater than 1. So everything except our first employee. Sorry, for a second there, I forgot I used the email for the customers. So a one doesn't make any sense for an email. And we get the rest of our names. So start, if you can find, I know time is a precious commodity. It's hard to find some, but these things take practice. So you're going to start practicing and put a simple database together and start with doing select queries with simple conditions. Try different conditions. I left that wildcard one there for you all to check into. And in particular, well, you all know this, there's lots of good material available on the internet. So you went to look at different tutorials. So I wanted to make sure there was at least one that I explicitly say, if you find time to get practice, go look this one up. And I'm not saying that to learn how to do this query, because if that's all I wanted, you could do that. I could just show you right now. What I want you to do is go use that as an example to choose a tutorial that you like. Because if we just go start searching, we're going to see a lot of tutorial sites, right? How to something different. How to select fields in MySQL. Yeah, I'll do a simpler one, but there's obviously the official documentation. MySQL select statement, they're going to talk about that. Selecting the keywords, retrieving the data, and we can scroll and scroll and scroll and go to more pages and lots of things, and not even come close to running out of tutorials. I don't see the one that I really like on here. So use that one that I didn't just directly tell you what it's supposed to look like. Look that up, but not to see what it looks like. I can just show you that directly. Use that, how to do a like query with how to select like with wildcard in MySQL, or in particular, we're in MariaDB if you want to. We're using MariaDB and look through some of those. Lots of tutorials. And I still don't see the one I like. Guru 99 is pretty good. But use that query to choose the tutorial site you like. Because that's the thing you're going to be doing most often, and the ones you want to get little refinements on. For now, just do simple selections with those. Select the field names you want and the table you want with the condition, and if anything, for this weekend, use that keyword to say join the teams. And if you join them, make sure you remember to say which table that field comes from. And the last thing I wanted to look at, employees had a skill set. This is where we should actually be using the JSON array, not as a data type. We saw that we had to adjust it. It has to go into a text column, but really what the reason it's in the language is so we can do JSON array when we select the employee ID from skill sets. Select JSON array with skill set. I can't remember what I called it in the skill set table. Go look at it again. Oh, it's in the picture. Skill set. Yeah, the equipment ID. So I'll give us the equipment ID. So equipment ID from employee joined with the skill set table, where employee ID is equal to skill set dot employee ID. That's how we should be using the JSON. When we get it back, that's going to grab all our skill sets, and it's grabbing them in terms of the employee ID or the primary key from the employee table matching the foreign key in the skill set table. It puts those together and then returns a JSON array of that, which I apparently made a typo because they're all size 0. Let me look at the picture again. So we want employee ID to match employee ID, which gives us equipment ID. No, I'll just do this instead. I'll cut that short. We're going to talk about joins. Why can I not find that? We have that in there, don't we? Oh, whoops. Never mind. It wasn't size 0. We just set every employee to only have. We forgot their skill sets. Let me do this. Delete that and delete that and delete that. Delete that. Delete that. Delete that. Find those insert queries over here. And those should be numbers. What do we have? Mower is number 1, so maybe a couple people are good with number 1. 1, 2, and 3. One's good with 1. This one's good with 4. This one's good with 2. There we go. So now that we have that data, if we go run that query again, there we go. So we start to see the array. It didn't give us, there's a first, it gives us every possible combination. Then it starts to break it down. That's not quite all the parts we need to see to put it together. So there's a little bit more coming, but that's where we want to use the JSON array when we get it back. And you'll want to start messing around with select queries. And it takes, like always, this takes a little bit of practice. Select queries are a lot more straightforward and come naturally to a lot of people, much, much easier than normalization. That's why I chose to talk about some of those other things. And while you're looking at those, use that to choose the choose a tutorial you like. Whoops. Select everything from skill set. Where one? There we go. We'll get all that data. You'll want to practice with those. They're usually straightforward. Look for some tutorials you like. DigitalOcean is my favorite place to look for MySQL tutorials. They have really, really nice stuff. Let me see if I can find it real quick. But don't go to their main page. How to do JSON array and select and Maria DB. This probably has it. Database got 30. Actually, is this the one I want? No, not Medium. Medium has some good stuff. Let me see if DigitalOcean is there. If you go directly to their site, they will want you to create an account and pay for them. But they have really, really nice tutorials, and they block things out in different colors. So they create everything, all of this, and eventually there should be a select structure somewhere, or select query. But it's nicely organized and color coded. Oh, so there, so that one's moved. Bunch of insert queries. There we go. Oh, they did JSON type instead of just JSON array. But that's one that I really like their tutorials. Use select queries and get a little bit of practice in. And select queries are very straightforward. We're going to get into doing better things with them next week. But you might want to start looking for a tutorial that you like, because there are lots of them out there for MySQL, and they all have different formatting and different ways of doing things. So some of them you won't agree with at all. You'll be more confused when you see how they write their SQL code. Then it moves the wrong direction. You get more confused instead of less. So find good tutorial sites you like. That's the main thing to start getting practice. Next Tuesday, we will continue with our joins and talk about the different types of joins, so that we don't have to look at our entire data set every time, because we almost never actually need to. And I will fix those typos, whatever that was, wherever the typo was with the constraint, I will fix that and send that file out, so you all will have the correct version of that and be able to see whatever was causing that typo that wasted a bunch of our time today. So more SQL next Tuesday, and then on Thursday, we will be in class for the last step of the group work. And please don't jump ahead and write SQL query just because it's designed, because I have other things that I want to throw in there when you go to write the SQL query. I want to be part of the group work, not just one person writing it. Otherwise, does anybody have any questions about stuff from today? Okay, I assume 5 seconds of silence means no questions. If you have any, let me know. Sorry about the typo that caused an error that I never did find and wasted like 10 minutes of our class time. I'll get that fixed after class and send the corrected version out to you. See you on Tuesday. Have a good one.